Good afternoon. So before we go any further, we'd just like to know your names and the institutions you're coming from.
My name is Andamoshi. I'm a PhD engineering student at the University.
Okay.
My name is Chawanangwa Chibeta. I'm a third year student at the University, pursuing a bachelor's program in computer engineering.
Amazing. So for you guys to be here for this physical residence, it means you took part in a hackathon. So just kind of tell us, which hackathon did you take part in?
It was pollution and visual mining.
Okay, and how was your overall experience from that hackathon?
The experience is nice. We learned a lot of things regarding the pollution that happens in mining areas and how we can help those polluted areas to reduce the contamination, because people's livelihoods have been destroyed, especially in Kankoya. Here, people don't farm that side, so we want to find a way to alleviate pollution and reduce the pollution levels in the area.
All right, interesting. So we would like to find out more about the problem you are addressing. I believe during the hackathon you addressed a certain problem to which you have been prototyping. So kindly tell us a bit about the problem that you were given and that you were addressing.
So during our hackathon in pollution and the future of mining, we are addressing about the problem of acid mine drainage.
Okay.
And how it destroys people's livelihoods in areas like Northwestern, the lead pollution that happens in Cabo and Mufulira, Kankoyo. So the mines do not detect the pollution they actually make, like the metals thing that happened. And also looking at the lead pollution we had in Cabo, which has led to multiple deaths to people. Like people have got neurological problems in Cabo. And also talking about Kankoyo in Mufulira, people do not farm that site. They destroy actually their livelihoods. So our system is mainly about detection of any minerals from the mines like lead, mercury, and...
Alright, so there could be potential investors out there who are interested in finding out or knowing how your solution works, and if possible they would like to see how the prototype you have come up with works. So could you tell us a bit about your solution and show us how your prototype works?
So on the technical side of the prototype, so we've managed to come up with at least a dashboard, more of something that people who would love to see the actual programming work, exactly how it's working. So here in front of the screen, if possible, if you can see, we have the live dashboard that's currently running on, was built in Next, and then the backend is built in Golang. So currently what we have is simulated data. So what we hope to build is a hybrid system that is incorporated with both the hardware as well as the software. So technically, if you've seen, maybe it might take about over a year for people that have or own farms to receive data or insights from the specialists that do the reporting from the ground. So technically, this system narrows down. Instead of getting those reports, imagine if a common person can easily get access to the current state of their land in less than 2 minutes, or at least every after 2 minutes. And not only that, but the thing with green features there is it just doesn't tell you if your land is not okay today or its current state. Imagine if you could have a system that's currently capable of telling you exactly how the land will be tomorrow, how your water supply will be in the next 1 week. Is the water going to be safe to drink? Not just today, but is it going to be safe to drink tomorrow or next week, or probably even next month? So what Green Features there also brings is two worlds in one system. So we have a dashboard. This is currently for environmental specialists. So here you're able to see stuff in color-coded displays per se. So you're able to see the pH level, the TDS, the turbidity, as well as the air quality. Not only that, but you also have the sensor network map. So the sensor network map is also color-coded as well. So if an environmental specialist came here, they're able to see different kinds of colors in different kinds of areas. So here they can easily say if the red is blinking, that means they could easily inspect that, for example, the Mufulira mining site. So once clicking on it, they'll be able to see the pH level, the TDS, the turbidity, as well as the air quality, as well as, since this follows the hybrid approach, they also need to monitor the current hardware of the system. So they need to know if the current hardware that's on the ground is failing or is still upright. So the system also displays the battery level, the last update, which was like 2 minutes, and the status, if it's danger or it's okay. But then, as we say, because of the incorporation of artificial intelligence, we don't only want to tell the specialists or the common people what they can know today, but we also want to provide more insight, such that we tell them exactly what they can know tomorrow, after a week, or even after a month. So it also provides AI prediction, which is, say, water quality expected to deteriorate in the next 6 hours, recommends immediate monitoring. Then again, of course, a person would want or would be curious to say, how sure can I be that this system is actually telling me the correct thing? If it says water supply might not be okay next week, that might be preventing them maybe from making certain decisions. So we want to know the confidence levels. So since we're implementing AI models, there's what is known as the AI confidence level. So each AI knows exactly how sure it is when it's giving prediction. So as you can see here, Bezo, we managed to test this on at least 50,000 data points, and we were able to achieve an AI accuracy score of at least 86%. So this currently shows the state or how confident the AI model is. So necessarily, apart from that, we have, of course, many features, as this is a very robust system. But maybe just, instead of talking about all of them, we can maybe just browse through the screens. So here we have the sensors. So on the sensors, if an environmental specialist is currently looking at it, they would be able to filter all those kinds of sensors. So we have different kinds of sensors, which are water sensors, air sensors, soil sensors, as well as just for reference. So if they come on water sensors and they want to check how the water sensors are currently faring on the Flira mining station, and they click on it, they'll be able to see to say, so this is a water type sensor. Its current battery status is 87%. The signal strength, meaning how is it able to communicate with our main server, which is like at least 95% signal strength. And the last update, what was the last data it pushed? How long was it? So here you can see to say for sure at least 2 minutes ago it managed to push the actual status on the ground. So again, it will show the pH level, the TDS, the temperature, as well as the dissolved O2. So necessarily that's how it is. But not only that, but it also shows the detected mineral contaminants, such as copper. Is it cobalt? Is it lead? Or is it zinc? Then apart from that, we also have the alerts. This is actually what tells the environmental specialist exactly what's going on. So here they'll be able to understand this. Again, if you can see, this kind of looks more high-tech or high-end. So this is just necessarily for someone, let's say like her, who's studying environmental science and is able to understand this. But like in terms of, in regards of, let's say a person who just wants to know, is it okay for me to farm today? Is it okay for me to drink water or use that water for other purposes? They can easily come to the login page. As I said, it supports 2 kinds of users. So I can easily log in as a user as well. Okay, let me just simulate a mobile view. Okay, so this is how it's going to look on a mobile phone. So the person when logging on Green Features AI, they can simply say user, then they'll log in with the account. Okay, so this is how simple it is for a person who just wants to know what to do. They don't really have to look at the pH value. They don't have to look at the air prediction score and all those things. So then once they log in, it will simply show them your water level and status. So it's going to show their current water quality status. So current status is not safe. So for anyone who would like to know why it's not safe, of course, I would love at least maybe some minimum explanation. So it will practically show them the pH level. So 3.9 and an explanation saying this is very acidic or dangerous. And it will also provide an explanation of what exactly that means, which is not safe for drinking or irrigation. But it just doesn't tell them the dangers, but also tells them at least further steps they can take, which is use treated water for all purposes in terms of drinking, farming, or maybe doing any other things. So necessarily, this is what Green Futures AI prototype is currently able to do, and we hope, of course, to build more if given the necessary tech that we need to at least advance the current stage of the prototype.
All right, amazing. So, Yansmari, just as we wrap up, how has Mukwa Unipod been of help to you and the team during your innovation, right from ideation all the way to this stage you are on, the prototyping, what help have you received from Nkuba Unipod?
So necessarily from the first day since we came here, personally I'm more of a hands-on person and I just love doing the programming. So when I came here I was told to write documentation and all those kinds of things, at least to have the proper state of the prototype I want to build. So necessarily at first that kind of felt, I could say, lack of better terms, maybe a little bit boring. But then when I tried to do the actual work, I realized how much I needed that documentation, for me to actually be able to build this. So I can say it provided a lot of guidance, but not only just guidance, but it also helped with the necessary machinery that I needed. Because currently I'm able to run this at least on a 13th generation laptop, so it was easy for me to effectively build a prototype that's currently working, and I was able to deliver this in a week.
Amazing. Thank you very much for sharing with us your innovation and the solution that you have brought to the world, and we wish you all the best as you continue refining your prototype. Thank you.